Hello everybody, in this video I will explain how we can calculate 3 by 3 matrices determinant in a quicker way. First I would like to solve it by using a usual definition, and then I will show you a quicker way to calculate it, and I will show you that both of them are equivalent. Okay, this is a 3 by 3. Any 3 by 3 matrices can be written like A11, A12, A13. The first indices says that is the first row. Second indices says to the column. So this is a second row, first column, second row, second column, and so on. This is the third row, first column, third row, second column, third row, third column. So we take any matrix and we would like to calculate the determinant. The definition of determinant, we focus on, in this example, the first row. You can focus on any row or any column. And this definition can be extended for any row and any column as a general definition, and they are all equivalent. Now, in this example, I'm focusing on only the first row. So the definition says how we calculate the determinant is as follows. So we take this element A11. So where is this A11 stated? The first row, first column. So we say -1 to the first row plus to the first row, first column. This is the indices for the row, that's the indices for the column. The 1 plus 1. Then what you do, you remove from like a visualize that you're removing the first row and the first column, and you're left with minor matrices here. That is A22, A32, A23, A33. And then we calculate the determinant of that. Actually, this notation and this absolute value notation is usually used for determinant in general. But let me write it down here, determinant, to make my point clear for you. So we would like to calculate the determinant of this smaller matrix and similarly of these matrices. And we know that to calculate the smaller matrices determinant, we need to multiply the main diagonal minus the opposite diagonal. So this one is called the main diagonal, and this one is called the opposite diagonal, because when we are multiplying the matrices, and this is the upper unit triangular matrices in that way. Anyway, it doesn't matter where it's coming from, but that is main diagonal, that is the opposite diagonal for me. The main diagonal with the green one, opposite diagonal is the yellow one for this bit. Then I need to think about this element, which is A12 plus A12, and -1 to the power of the position. The position is first row, second column. This is why I have 1 plus 2 here. And then the determinant, when I am removing the first row, second column, whatever is left as a minor matrices. That is A21, remove from your eyes this one and this one. We have A21, A31, A21, A31, and A23, A33, A23, A33. And then we need to calculate the determinant of that one. Plus A13, that entry. This entry is the first row, third column. So this is -1 to the power of the position, the first row, third column. This is why we have 1 plus 3 here. And then the determinant of the minor, that is when we remove to the first row and the first column, whatever it's left here. We have 2, 1, 2, 2, 3, 1, 3, 2, 2, 1, 3, 1, 2, 2, 3, 2. Now, we will call, this is the determinant calculation with respect to the first row. You can do this definition with respect to the second row, with respect to the third row. In that case, it's the same logic. You will have 2, 1 here, and then you will say it as a position that is the second row, first column. You will have -1 to the power of second row, which is 2 plus 1. And then your determinant is a minor. You will remove the first column, second row, and then whatever it's left, that will be the determination, the determinant, and so on. I mean, the logic is same. You will use this logic. You can use this logic for any row, for any column, to open it up, these 3 by 3 matrices, and write it down in terms of the determinant of 2 by 2 matrices. Okay, this is a definition, and we calculated these little determinants and find out how it looks like in the end. So this is A11 here. So A22 times A23 minus A23, A32. That's that guy. So minus A12, there's A12 here. Minus 1, so this is over the third power, so it is negative. So there's a negative here. And then the determinant of this matrix, A21, A33, A21, A33, sorry, and minus opposite diagonal, A23, A31, A23, A31. Okay, now the third one, A13 times the determinant of this. This one will give us plus, because minus 1 to the power 4 is plus. The determinant of this one is A21, A232, A21, A32, minus the opposite diagonal, which is A22, A31. So what we have from here is this equality. Now let's get the positive ones in one place and negative ones in one place. That's the next step that I've done here. So this is positive A11, A22, A33, yeah? And then this minus times this, that will be positive. This is A12, A31, A23. That's that guy. Then we have A13, A21, A32. This guy, which is this one here, is the positive ones. And now the negative ones. I'm organizing positive ones minus and the negative ones. That's a negative one, A11 minus A11, A32, A23. Another negative one here, minus A12, A21, A21, A33, A33. Another negative one comes from this corner, A13, A13, A22, A22. A31, A31. Okay, right. So this determinant is equal to this number, whatever it is, for any AIs. AIs are any real numbers. Now the quick way, and I will show that this is exactly the same. Yeah. Okay, the quick way, if you get used to do it with your eyes, your brain will do it much more quickly. So this is why I am saying that this is a really quick way, because you will be eliminating a few steps among them. Okay, so I am focusing for the positive side, for the positive members of the determinant, I'm focusing on the main diagonal. So I'm multiplying them. A11, A22, A33, A11, A23, A33. And then I'm thinking this certain symmetric points. This one, this one, this one. That is A31, A31, A12, A12, A23, A23. And then another symmetric one is this one, this one, this one. A21, A32, and A13. Okay, now this is that section. Now I am focusing on my eye with the opposite diagonals. I wrote it here for the reference in order to be able to make to see what is going on. But once you get used to it, your brain will do it automatically. It will be much more quicker. So this is the opposite diagonal. So these are the negative ones. So that is A13, A13, A22, A22, A31, A31. And then we have the symmetric, some kind of a symmetric entries. So the entries that I'm thinking as a symmetric is this. It is A11, A23, A32, A11, A23, A32. Then another similar symmetric entry, this one, and this one. That is A21 times A12, A21, A12, and A33. Okay, this is the determinant of 3 by 3 matrix. And now let's see, this is equivalent to the ones that we found. What I mean by that, this is equivalent to that one. So this one here, A11, A22, A33, is this one. This positive one, 1, 2, 3, 1, 2, 3, is this one. 1, 2, 2, 3, 3, 1, this one. And this one here, A21, A21, A32, A32, A13, A13. So this one is equal to that one. Now let's have a look at the negative ones. A11, A32, A23. This is that one. A11, A23, A32. So that this just falls in this case. But this one is equivalent to that one. And this one is equivalent to that one. A21, A12, A33. And this one is equal to that one. 1, 3, 2, 2, 3, 1. So these are equivalent. Whatever the method that you would like to use, you're welcome. As long as you can calculate the determinant of 3 by 3 matrices. Yeah, this is a quick way of doing it. This is from the definition of it. When you have the numbers, it will be easier to figure it out. So instead of having this line, for example, or this line, for example, you can do it from your mind, and you can, or you don't need this one. You can do it with your mind, and you can obtain this formula in one line. Your brain can do that very easily. So in this way, you're going to obtain that way. It's up to you, whatever works for you. Okay, that's it for this one. Thank you very much.